Okay, folks, so in this section we want to look at our difference quotient for radical functions. So we've already studied the difference quotient and we've worked with it with quadratic expressions or polynomial expressions, but we haven't done it for radical functions. So let's just recall the difference quotient that we derived before, and then I'll just say in class we'll remind ourselves why we are developing this difference quotient. So the word is difference quotient. And the definition for when we have f of x is that we could say that the average rate of change, which is the same thing as the slope of the secant line between x and x plus h, that this is equal to f of x plus h minus f of x all over h. And you should always state this part when asked to do one of these difference quotient problems. And I would encourage you to say both of these things as well, because I think it keeps you in the right mindset for what you'll need for Calculus 1. Okay, so what I'd like you to do is on your own, I'd like you to pause the video and I'd like you to rework the difference quotient, not for what we're going to work today, but just to remind yourself of how we worked with the difference quotient for our polynomial expressions. So pause the video and give this one a shot. Okay, folks, so before we jump into doing the difference quotient for radical functions, I want to make sure that we're all good to go with some of our square root operations. So let's, I'm going to leapfrog with you on some problems. I'll do one, then you'll try something very similar. So let's practice multiplying out some radical expressions here. So we've got the product of x plus the square root of 5 being multiplied to the factor x minus the square root of 2, so we're trying to compute that product. And remember how we multiply one binomial to another. So I'm going to multiply each term in this binomial to each term in this binomial. So we get x times x, which is x squared. Then we'd have plus x times minus the square root of 2, plus the square root of 5 times x. And then for the last, we would get the square root of 5 times negative square root of 2. And if we clean things up, we get x squared minus the square root of 2x plus the square root of 5x, and then minus the square root of 10, remembering how we can work with those radicals. There is one simplifying we can do. I'm perfectly fine with you leaving your answer here, but these are both linear terms, so we could group them together as plus the square root of 5 minus the square root of 2 times x, where I factored an x from those two expressions. I also did some rearranging as we did that. So that's another acceptable place, I think, to leave your answer. So what I'd like you to do is pause the video. I want you to work the same thing. It's very similar, and then we'll resume in the next problem. So folks, this will be one of the things I check for in your work, so make sure you work through that. If you get stuck, you've got all sorts of online resources to help you out, plus you've got the example I gave where you're just literally lining things up. You replace the x with a y, you replace the square root of 5 with minus the square root of 3, and do the exact same work that we just did. Give that a shot, and I'll jump into this next problem. So now we've got the product of the square root of x plus the square root of y times the square root of x minus the square root of y. And so if we expand this out, we would get the square root of x times the square root of x plus the square root of x times minus the square root of y plus the square root of y times the square root of x, and then plus the square root of y times minus the square root of y. And you can certainly simplify as you go, folks. Let's go ahead and assume that x is greater than or equal to 0 here. And so then this would give me x minus the square root of xy plus the square root of xy minus y. And when we clean everything up, we just get the expression x minus y there. Okay. So folks, we're practicing multiplying out these radicals together. When I multiply the square root of x times minus the square root of y, that's where I got minus square root of xy. And similarly here, and of course what we see is that when I have two binomials where they differ by just the sign in the middle, those middle terms will always add out. So let's have you pause the video and give this one a shot, and I'll see you in a moment. So folks, hopefully you worked that problem. Let's go ahead and look at the last two here. We now want to do the last two of these problems. I'm going to work 2, you're going to work 2. So we'll take the square root of x plus the square root of x plus h, and we're going to multiply that to the square root of x minus the square root of x plus h. I'm going to do this just a little bit faster now, folks, as I go through. I'm going to simplify as I go. So when I multiply radical x times radical x, that gives me radical x squared, which for x squared and equal to 0 would just give me x. For my next expression, I'm going to multiply radical x to this, so this gives me minus the square root of x plus h, where I went ahead and put the minus sign out front. Then I will do this product here, so that would give me plus the square root of x plus h. And then for my last, I'm going to get minus the square root of x plus h quantity squared, and I could have simplified that already. I want to point out that we get x. Here the outers and inners add out, and that will always happen whenever the two binomials differ by only that sign. They're called conjugates of each other when they differ by just a sign, so that will always happen. And then I'm going to get minus parentheses x plus h. And be very careful with this, folks. We do need that parentheses right there because why? We need to distribute that minus sign to both terms inside the radicand. So this gives me x minus h, which just simplifies all the way down in this case to minus h. Okay. So pause the video, give it a shot. I'd like you to try letter F. So folks, you should have found that the answer to letter F was minus b, but of course you need to show the work like we did over here. Okay, so for this last problem, we're going to give it another shot. And again, we're practicing how this might show up in our difference quotient. So here, as I FOIL this out, I'm going to do this a little bit faster, folks. I'm just going to talk through it. We're multiplying the square root of a plus b to the square root of a plus b. That just gives me a plus b. My outers would give me an expression. My inners give me the opposite of that expression, so those add out. And for my lasts, I would just get minus a. And careful here, folks, I'm going to put that in parentheses because like we saw above, if we didn't put it in parentheses, we need to remember to distribute that minus sign through if we had some sort of binomial. And in this case, then, everything just simplifies to b. So give that a shot here, folks, with this one. Do the work. If you can't do this in your head like I did here in letter G, then do it slowly like we did in letter E. Give that a shot. And then I'll see you in the next video.